Okay, this is the next tutorial. This is tutorial number 3, where we are going to work with Foundry on a forked environments. And if we go to the documentation, we can see that now we'll need to interact with CCIP Local Simulator fork smart contract, which needs to be imported from Chainlink Local, SRC CCIP, then CCIP Local Simulator fork.sl, not CCIP Local Simulator. And also here we can see its usage. So again, we will just create a new instance of it using CCIP Local Simulator fork equals the new CCIP Local Simulator fork. And also we're just going to make it persistent by providing this command vm make persistence. That means that because we're going to switch between multiple different forks and multiple different forks in Foundry, we want this smart contract to be present on each of those networks, so we can perform our tests and scripts correctly. Here I basically created two, but I will need basically to create two or more forked network environments. So I'll need just to provide RPC URLs for archival nodes, and then I can see that I can just interact with my sender contract as usual. And when I want to receive a message, I will call this switch chain and route message function, which does exactly what is in the name of the function. So it's switch to a different fork. So imagine now you're in Ethereum Sepolia, Ethereum Sepolia fork, you want to send a cross-chain message to Arbitrum Sepolia fork using CCIP Local Simulator. So you're going to perform all the actions needed on Ethereum Sepolia fork, and then by calling switch chain and route message, simulator will under the hood collect all the events currently emitted so far. It will look for the specific CCIP send requested event. It will grab the message object from that event in the same way that that committing done do that, and it will form it'll form a cross-chain message which will be rerouted using router on the other side, on the other copy, on the other fork, and it will stay on that fork. It will after this function exits correctly, the state of the blockchain will be on Arbitrum Sepolia fork. And here we need to provide fork ID. So fork ID is the ID of the destination fork. So these two forks, so Sepolia fork, Arbitrum Sepolia forks, not chain IDs, not chain selectors, but actual Foundry forks. This is why this works only in Foundry environment. There is a different script in Hardhead, in TypeScript for Hardhead. There is also a function to request link from faucet, and also a function to get network details. And to get network details, you're gonna provide chain ID, and network details will be returned from the register smart contract. We will see that. We'll basically return a struct or a tuple containing chain selector, router addresses, linked addresses, rep native, and CCP BNM and LNM. So for all currently supported test networks, you can provide just chain ID. So for Sepolia, there'll be 111.55.111 for Ethereum Sepolia. So this is the actual blockchain ID. Also, if your test network or any main network, so mainnets are not supported, is not supported, you can easily call set network details. And now you can set network details and support your network. You're just gonna grab details from the official Chainlink documentation. Or if you don't want to bother with these two functions, you're just gonna provide manually addresses of all of these contracts inside your test file. Yes, because you can grab all of those from the Chainlink documentation, and you're basically interacting with the real world testnet smart contracts. So you don't need to worry about any other config. So yeah, let's see this in action now. So we're gonna again use CCP sender and receiver, sender unsafe and receiver unsafe we used to, and I also started to create a little test so to speed us up. So we have CCP Local Simulator fork here. We created these two fork IDs here actually, fork IDs. These are coming from my .env file, which is here, but I'm not going to show it. Do not increase my alchemy bill. And I'm creating a new instance of CCIP Local Simulator fork and making it persistent. This is red because I'll need to import register contract as well, which should be available in this file, which is correct. Okay, cool. Now with Sepolia network details, as being said, I will return a tuple or a struct called network details from the register smart contract containing all the necessary config addresses, which I can also grab from the official chain documentation. This is handy because I can always use blockchain ID. So if I switch fork now to Arbitrum Sepolia, I can also use blockchain ID and get Arbitrum Sepolia network details, because Foundry will under the hood also change the chain ID to the correct network fork. So this is a handy way to get the details of all the CCIP contracts without going to official documentation to copy paste them. Okay, cool. So let's deploy, because now, okay, what we did, we are creating and selecting fork for Ethereum Sepolia and creating fork for Arbitrum Sepolia. So we are now on Ethereum Sepolia. So if we are on Ethereum Sepolia, we would like to deploy the sender smart contract. So to do that, we're gonna actually do something like this. So CCIP sender unsafe, public sender, and let's do receiver while we're here, public receiver, and here, so sender, sender equals to new CCIP sender unsafe, and we need to provide the address of a link token and the address of a router token. So we can do that by Sepolia network details dot link token address. Again, if you're not sure what to put here, you can always go back to documentation and see the exactly details. So get network details. So actually it's not link token addresses, link address and router address. So here I can see what I need to put. So link address and router address, right? So if I go back to Visual Studio Code, this needs to be link address. And for the router, there'll be Sepolia network details, router address. Also, our sender contract, as you already know, needs to have some amount of CCP BNM, right? So I will need to interact with CCP BNM. So to do that, I can always refer to burn and mint 677 token, and I'm gonna just import that from CCIP Local Simulator. So to do that, I'm gonna do like in the previous test. So import burn mint helper from this is not right. So Chainlink local burn mint helper. Okay, cool. That should work. So what I'm gonna do is I'm now gonna create an instance of CCIP BNM like this. So here is fine. So there'll be CCIP BNM Ethereum Sepolia, and CCIP BNM Ethereum Sepolia is equal to new burn min 677 helper, which I actually don't need to do like this, but I will just provide address using Sepolia like this. Sepolia network details and then CCIP BNM address. So I'm not deploying the contract, I'm just creating an instance because this smart contract already exists. Now this is much better. Okay, cool. Now using CCIP BNM Ethereum Sepolia, I can call the drip function and provide the address of a sender. And now our sender should have one CCIP BNM. We can actually test that, right? We can actually test that. So let's actually make sure that we are on Sepolia. So what I'm gonna do now is I'm gonna just make sure to select the fork. So there'll be VM select fork first before doing anything else. So VM select fork, there'll be Sepolia fork, and then console log CCIP BNM Ethereum Sepolia balance of address sender, just to make sure that this worked right. So let's do forge test VV. Will this work? Oh, will not, because I'll need to import console. And let's import it from previous test. That'll be the easiest way. Yeah, console like this. So console like this. Okay, cool. Forge test. Let's see, did we break anything? Shouldn't, but let's validate anyways. Okay, cool. So we can see the balance of address, and here it is. So logs, blah, blah. This is our previous test mode. So everything's fine, so drip worked. What I can also do is, as we saw on the documentation, CCIP Local Simulator fork, request link from faucet, and I'm gonna request address sender 5 link. So let's cover that. That's for fees, basically. Okay, cool. Now I can even delete this. I don't need that. So now what I can do is, in my setup function, I will do VM select fork to Arbitrum Sepolia fork. And what I'm gonna do is I'm gonna deploy a receiver contract. So receiver equals new CCIP receiver unsafe, and I need to provide the address of a router here. So to get the address of a router, what I'm gonna do is I'm gonna call network details once again. So there'll be, let's see if I have, yeah, Arbitrum network Sepolia details, so Arbitrum network, let's grab it from here. So like this, so Arbitrum network Sepolia details will equal to CCIP local simulator fork, get network details of, again, block.chainid. And now I'm gonna just provide Arbitrum network details of router address, and this is it. This should work, so let's quickly run forge test one more time. And this should be all the setup we need to perform. I can even now, you already know that we need to now call allow list sender and to check the text. So I'm gonna just collapse all of that so we have like a better view on the code we are working with currently. Cool, so let's quickly allow list that. So there'll be receiver allow list sender, there'll be address of sender and true. If we don't do that, we'll have an error. I can actually leave that as is for now. So now I'm selecting fork. I'm on Ethereum Sepolia again. So I'm gonna say sender send, and if we go back to sender, we should be able to see receiver, some text, chain selector, token amount. Okay, so there'll be address of a receiver, some text, chain selector, there'll be Arbitrum Sepolia network details dot chain selector. Token we're sending is Sepolia network details, so we're on Ethereum Sepolia, equals CCIP B an M address. Is that correct? Yeah, address. And amount we're sending is amount sent. And let's quickly add those two. String memory, some text. Again, we can do hello forking. And doing 256 amount to send, we're gonna do again one. Oh, actually, let's do the whole thing. One CCP BNM. Okay, cool. Now, if I run forge test, this should work. Remember, this should work now. Even though we haven't allowed listed sender yet, assuming we don't have any syntax errors. Hopefully, we'll see. Let's see. Spin up all the forks. Okay, cool. Everything's green. This is work. Why? Because this is the whole process on the source blockchain. So everything on Ethereum Sepolia is done. Events get emitted. Now what I need to do is call the CCP Local Simulator fork, switch chain and route message. And then when we switch chain and route message, we should encounter an error on the receiver side. Because only at that moment the underscore CCP receive function will be called. So if I do CCP Local Simulator fork, switch chain and route message, and I'm gonna do Arbitrum Sepolia fork, so I'm gonna switch to this chain now, I should see the error, right? Forge test VVV. Okay, cool. Receiver error will still see the function selector of the selector of a custom error and some address which we can validate it's a sender. So it's probably the same, not probably, but it is the same error. So if I now call the allow list sender function first, this error should now go away because we now fix it, and only at this point we are switching to another network and we are routing the message by calling the CCP receive. So we are now on Arbitrum Sepolia fork. Now, let's quickly just wait for this test to get executed. Okay, everything's green, that's what we want. Now, what if we want to include more than two chains? Well, what if, for example, we have CCP receiver, and here, after the CCP receive, we maybe want to send another message, right? We want to create a new message and to send it to some third chain, to, let's say, send message to Optimism Sepolia now. So I'll just comment this thing to save us time. So what I'll need to do is pretty much the same thing. So I'll create string memory Optimism Sepolia RPC URL, and there'll be, grab this VM env string, put it here. And then I'll create Optimism Sepolia fork. So that'll be Unit 256 Optimism Sepolia fork. And I'll say, okay, now Optimism Sepolia fork is VM create fork. And that'll be this one. And now let's see what's going on. So here, if my CCP receiver receive a message and then send an instant message to a third chain, Here, if that transaction is successful, that means that we were on Ethereum Sepolia, called the send function. Router delivered the send function, locked tokens on the source chain, emitted event. When we switched to another chain and route message, we picked up those events, route message to the receiver on Arbitrum Sepolia, and if that receiver also sent another message, that means that the router on Arbitrum Sepolia will again lock contracts or lock tokens or burn tokens, depends on the token mechanism, and emits an event and stop. So this is all gonna happen if that transaction is successful. So if I want now to receive the message on Optimism Sepolia, assuming I created a receiver in Optimism Sepolia, which I did, what I will just do is I will just do CCIP Local Simulator fork switch chain and route message to Optimism Sepolia fork and just run my test one more time. And this is the whole process. Now, if you want to do some other stuff here in a test, so one function, two function, whatever, and then call CCIP send again, what you can do is eventually call CCIP Local Simulator fork, switch chain, and route message now to Sepolia fork again, and then receive, etc. So this is the whole flow. This is how you can basically interact with all the CCP supported chains in a single test or a script using Foundry, as long as you correctly created all these Foundry forks. So yeah, that'll be it for this example number 3. See you soon in example number 4.